Hello, welcome to Computational Methods in Bioinformatics Week 6 class. Today we are going to see advanced deep learning architectures. So let's start. Well, we have simple architecture, it's called Alexnet 5. It was actually the original deep learning paper, convolutional neural network paper, written by Alexnet. It's pretty old paper. It was published in 1998. As you can see here, these are very similar to what we have already seen as CNN. We have an image here, and we use convolutions to obtain a lot of feature maps, and then we do pooling, and then we do another convolution layer, and then we obtain another pooling layer, and then we use flattening to convert these outputs, feature maps, to actually a flattened layer to supply to the fully connected network. It contains two hidden networks and one output layer. It was actually the original deep learning paper, convolutional neural network paper, written by Alexnet. It's pretty old paper. It was published in 1998. As you can see here, these are very similar to what we have already seen as CNN. We have an image here, and we use convolutions to obtain a lot of feature maps, and then we do pooling, and then we do another convolution layer, and then we obtain another pooling layer, and then we use flattening to convert these outputs, feature maps, to actually a flattened layer to supply to the fully connected layer, fully connected network. It contains two hidden networks and one output layer. So as you can see, excluding the output layer and the image map, we have 5 layers. In the first convolution layer, they use 5 by 5 convolutional filters. They use try to value as 1. And in order to do pooling, they use subsampling, actually the averaging. So the pooling was obtained by 2 by 2 masks, and its stride value was 2. They repeated the same filters and same pooling operation, and then they obtained a flattened layer. So the architecture can be seen as convolutional pool, convolutional filter layer, convolution maps, pool, and fully connected and fully connected. So this is very similar to what we have already seen. But the deep learning was sparked mostly by ImageNet challenges. The ImageNet project is a large-scale visual database designed for use in visual object recognition software research. So its purpose was to generate a challenge to understand, to recognize what object is inside the picture. So it included 14 million images, and they all have been annotated by people. In the annotations, people just indicated what objects in the picture, and also at least in at least 1 million of the images, people just outlined the bound. People also outlined the bounding boxes of the pictures. So ImageNet is a large database. It contains more than 20,000 categories, and typical categories such as balloon and strawberries has a lot of samples. I mean, for balloon class, for instance, balloon category, it consists several hundred images. So in ImageNet competition, there was actually one challenge each year. Actually, in the first 2 years, researchers just used shallow networks such as classical machine learning algorithms. In 2012, Krzyzewski and his friends used 8 layers convolutional neural networks and won the competition. In shallow networks, the error was really high, but Alexnet provided beautiful error figure. It's 16.4. So let's inspect Alexnet. It is 8-layer neural network. First 5 is convolutional layers, and final 3 is fully connected layers. As you can see here, but the Alexnet contained a lot of convolutional maps. For instance, it had for instance, it had 48 It is a very large network. It consisted of 8 layers. The first 5 layers were convolutional one, and the final 3 layers are actually fully connected layers. It also consisted a lot of filters, convolutional filters, so a lot of convolutional maps. For instance, here in the first convolutional layer, it consists of 48 feature maps, convolutional maps. In order to generate this map, they used 11 by 11 convolutional filters, and then by using 5 by 5 max pooling, they generated second layer. So let's inspect Alexnet. It is a pretty large network, and it contains a lot of parameters to train. It actually didn't fit the one GPU, so they divided all the network to 2 GPUs. They use GTX 580 GPU. It contains 3 gigabytes of memory. So network spread across 2 GPUs. Half of the network is consisted in the first GPU, and second half of the network was consisted in second GPU. It consists of 8 layers, including output layer. So in the first 5 layer, they used convolutional maps, and in final 3 layers, they used fully connected layers. So let's inspect the first convolutional layer. convolutional layer, they used 11 by 11 filters, convolutional filters, and the number of filters were 48. So obtained 48 output maps, convolutional maps here. And then by using 5.5 by 5 max pooling, they generated second convolutional layer. It consisted 128 convolutional maps by using that number of filters. Then in the second layer they used 3 by 3 max pooling and then generated third convolutional layer. In the third convolutional layer they used 192 convolutional filters. And then in the next layer they used also 192 convolutional filters using same amount of max pooling and 3 by 3, and the convolutional maps were 13 by 13. And in the final convolutional layer they used 128 convolutional filters, but the size was same in the final convolutional layer with the previous three ones. So the size was 13 by 13. And then they used dense layers to do the classification. The network consisted two dense layers and one dense output layer. So as you can see, there are a lot of parameters to train.